Very cool, huh? I love toys.
I love Legos.
Raise lower. I think people will pay for us just to sit here and play with this for half an hour. I think that'll work.
We could put it online, let them control it.
We could. So hello and welcome back, everybody. My name is Pete Brown, and I'm a developer evangelist at Microsoft, and I play with toys for a living.
And I'm Eric Haver. I play with toys for a living, too. What a coincidence.
Isn't that awesome?
Yeah. Yeah, I'm a developer evangelist as well, and I focus in on experience. So a lot of the things that I'm doing have to do with either design or with tangible things like these Lego bots here, which are a lot of fun.
Very nice.
And I've worked with things like Surface when it was a tabletop device over the years, back in those days.
And your office is the one I've gone into to use the Pixel Sense.
The Perceptive Pixel.
The Perceptive Pixel.
I do have a Pixel Sense as well.
Yes, you do have the Pixel Sense. Pixel Sense Perceptive Pixel, right?
That's right.
You've got that on your wall.
Yeah, love those big screens. Those are a lot of fun.
So if you visit Microsoft and you're looking for an office to hang out in, I think yours would be a pretty decent candidate.
We won't tell them where it is because
we won't
walk off with something.
Gavin Gear, do you know Gavin by any chance?
Yep.
So Gavin's office is another one that's really cool to hang out with because he's the guy that does 4K gaming across 4 screens at the same time. 4 4K screens and he's playing a game on it. So you want to talk about excessive? That's like $60,000 worth of displays right there. So
I try to keep it under 10 or 20.
Yeah. So I think we'll focus on more toy stuff here on this.
Yeah.
And for the first time, we can talk about something and say it's just a toy, and it's true.
It's
true. Okay, great. So we're going to talk about USB and robotics here today, and robotics, of course, in the context of the Lego Mindstorms EV3 stuff. So this is really exciting stuff. If you have children, or you are a child at heart, or you just like to play with toys, this is some really cool things to play with. But why are we going to talk about that this afternoon? We want to talk about it in the context of USB. Right? So there are lots of different types of peripherals that are supported in Windows. You can have Bluetooth devices, which we'll show a little bit there and then much more of later. Point of sale and service, which we'll talk about much later. Human interface devices, which surprisingly this actually is. WinUSB, geolocation, 3D printers, which we just covered in the previous session, scanners, fingerprints, virtual smart cards, all sorts of stuff are enabled either through updated or new APIs in Windows 8.1. All right. And so what we're going to talk about specifically in this section, in the context of Lego, is USB. So, and the printer's running over there. Can we get a shot of the printer again for just a second? Because if you missed the last session, you missed starting off the 3D print here. So we've just sort of let it run, and I'm going to get some cool toys out of this at the end. So, okay, cool. So human interface device. A human interface device is defined that way because you would think it's something that, like a keyboard or a mouse or some other thing that a person is going to use to interact with the computer. But that's also been expanded over time to get things that are sort of arguably not really human interface devices, like things like Lego and other stuff that we're going to talk about. This is enabled through the WinRT API, Windows Devices Human Interface Device API, and you can have custom devices, hobby devices, all sorts of really cool things in there. I love NetDuino stuff. I've done a lot with NetDuino, and kudos to Chris Walker and his team for what they've put together over time. And the same thing with the folks that have been working on Gadgeteer. These people all created .NET Micro Framework devices that we can use with HID, Human Interface Device APIs to be able to interact with our computers and everything. In fact, a person today had said something about a limitation about a particular device that they were using where it was a point-of-sale device, but because it was an old screen, it had really thick bezels, and they have a hard time flicking the charms in from the right because it had just giant bezels on this. I mean, like chunky bezels like that, right? And so they had a hard time flicking in. I said, there are a bunch of different ways that we can fix this, but if you want to do the geek thing, you can go and get a NetDuino or an Arduino or a Gadgeteer and create a HID keyboard device, which has its own separate API in here, and have it send the hotkeys to invoke the charms. So you can just have this little button on the side that you press and it invokes the charms. And this is a point-of-sale device. It didn't have the keyboard actually attached with it. So I think that's kind of a cool idea. And thank you to whoever it was in the chat that had pointed out that problem and gave me something interesting to talk about here for the last 2 minutes. All the devices that are HID devices, or HID, human interface device, right? All the HID things here must work with the Microsoft provided classes. And the reason is, they need to work with inbox drivers and inbox classes because they need to work on RT-based devices. So Microsoft provided drivers are available to everyone. There's also, third-party filter drivers that you can access, if you're creating a device app, but that's not what we're talking about here. The supported device classes prevent conflict with the built-in functionality. Like we don't necessarily want you to create your own implementation of a HID keyboard API because we have classes that already support that. You could create your own device, but you're going to want to use the built-in normal text APIs and stuff to do that. So there are a number of different unsupported devices here, and I bring them up as unsupported because you want to know that there are other APIs that support those, magstripe readers and barcode scanners and sensors and things like that. I'd mentioned Arduino before. Again, I'm a big fan of all things .NET Micro Framework. So if you have a device that doesn't fit a standard USB device class, or you don't want to use HID, then in fact you can use windows.devices.usb and just write to these things using serial type streams, using data reader and data writer. We'll be doing that a little bit later with Bluetooth in one of the next sessions here. And Windows Store apps can update the device firmware even in the background, so there's some really great functionality there. Again, all this stuff is now enabled with Windows 8.1. A bunch of different supported device classes for WinUSB, like USB serial, physical, like healthcare, stuff like that. And again, there are some unsupported devices, just like we were talking about before, where we don't want you necessarily using this interface to create audio or create your own HID or create images and stuff because we have other APIs to support that. Okay, so let's talk a little bit there. Excuse me. Let's talk a little bit here about Lego, and then take a look at some of the demos that we have. So, Eric, you worked with Lego specifically on some stuff. Can you talk a little bit about that?
Right. Yeah, I've been working with Lego for a few years on a variety of projects. And one of the things that we did last year for Build is we were talking to the Windows team and wanting to look at something where we could take advantage of HID and the devices. And obviously we have Sphero and these different kind of objects that we'd like to play with. But Lego really had an interesting opportunity. The Lego education team, they're very active in STEM education, the science, technology, engineering, and math.
Yep.
Yeah, right, I got them all. I think actually design should be in there somewhere. But but Lego has been very active in the community, in the schools, and teaching kids about 21st century skills, to be able to become developers like a lot of you that are watching right now. And Microsoft is very active in that space. We have a lot of people, yourself included, working with Lego, with robot leagues. And
yeah, so
and
I just a couple of weekends ago, I was one of the judges for it's a VEX robot competition that was up in Baltimore. I live near Washington D.C., so up there, and it was absolutely amazing to me to see what kids in 7th grade through 12th grade were putting together, because they were putting together really sophisticated robots and doing some pretty amazing stuff. And there's also, you said like Lego Leagues, there's Lego First Robotics League, and then that can expand into the larger First Robotics League,
right?
Where I've seen, if you want to see some really amazing stuff, at the high school level, the First Robotics League was creating these huge robots that had to be able to reach up to be able to put a basketball in a hoop. And those types of
They've
things.
got the metal construction on them.
Yeah, they're
right?
metal.
Yep.
They're given like $10,000 of seed money to come up. They're given a mentor. They have sponsorships like NASCAR. Like there's stickers all over it, but instead of it being like kinds of beer and kinds of tires, it's like NASA and Raytheon, or I guess not Raytheon anymore, right? But like all those different kinds of companies that are into that. So very, very exciting.
Yeah, it's very, very exciting stuff. And Lego kind of spans. They have the We Do, which is their line for primary schools. So you have a lot of kids that aren't quite into the heavy-duty programming. And with Mindstorms, you get a little bit more technical in terms of the loops and functions that you can do within the programming. We Do is for the younger kids, and it's a USB connected device. Only sold to school systems. And then you get into retail, and you have the Lego Mindstorms EV3, which was just coming out last year. So when we were looking for something to do at Build and talk about USB and the great things that were coming out with Windows 8.1, we thought, why not talk to Lego about this? And we were both really excited about it, both Lego and Microsoft. We came together and came up with a scenario where we could have a bot and extend that with the PC so that the PC was sitting on the bot it had the camera and the sensor there because, Lego has a certain amount of sensors.
Yep.
They don't have every sensor you can imagine. And one of the things they found intriguing about using the PC is that you can extend that, right?
So it was a Surface Pro, I believe, right?
It was a Surface Pro.
Surface Pro just sitting on top of the robot.
It was a 2-pound device, so
Right.
you can imagine infrastructure. This little guy here is built with a retail kit. So this is something you can pretty much build. I've built it to hold a phone on here, so you could have a Skype session open while you're connected via Bluetooth and controlling it via PC.
Yeah.
Kind of see where you're going. We had a big version of that. So we had several kits that went into this big bot, and it had a turret on it, and it had the Surface Pro on it. Mm-hmm. And then that was connected via USB to the bot itself. So there's a little USB
onboard
port on
PC
here.
tethered to the brain.
the bot. Yep.
What do you call
the brain? There's a couple names for it. We'll call it the brain.
Okay, so tethered to the brain via
Yep.
USB, and
Control brick, I think.
Yeah,
is one.
controlling it.
Yep.
And then you had somebody else with another PC. You said?
Exactly. And so Antoine Laban had another Surface Pro that we had network connected up to it, and he was able to control that, see what the robot was seeing, and be able to control the bot. We had a few things we didn't show there. We had we used face tracking from MSR that allowed the turret would actually track the person who was in front of it and be able to kind of follow it and rotate and follow them around on the screen, which was kind of cool too.
So somebody who's into building this type of stuff,
right,
could, whether they're a kid, could be 14 years old, seems like a good age to really be into
Right.
this stuff, right? So a kid could take their tablet, we're going to go with Windows here because we have some APIs we want to talk about, have a Windows tablet on this device and create a really sophisticated, intelligent robot
Right.
that has the power of a PC as the brain.
Exactly. And I think what's kind of cool is, now with the Venue 8 Pro, which I have,
Yes,
which is
yep.
a nice, small,
Really
compact
light,
one.
8-inch tablet.
Yeah, you can pretty much fit that on top of one of these, and it really expands the possibilities of what you can do.
Yeah.
And in fact, one of our things we wanted to do was inspire people and say, hey, here's what we did, but we know as a community, you guys can think up all sorts of amazing stuff. And if you go on YouTube, right, you can see just
Of course, right?
thousands of ideas. Take that, and we put out a little API which you can hit at Lego EV3.
Got it up here on the screen.
Excellent.
We show this, right?
And you can go get that API, and it's really easy to start up with and get something going. In fact, you did something really quick here.
I did, but let's take a look at so this is on Codeplex, right? We have the source codes all available to it, or for it, I believe.
Right.
And this API will support WinRT apps, right? So modern apps. It'll support desktop apps.
Right.
And phone, correct?
Yes. Yep.
And,
all three.
And the API is pretty much identical between all of them because we hide the complexity underneath.
Yeah.
And who is it that put this together?
Brian Peak, one of our developer evangelists, did an amazing job.
So huge shout out to Brian. Brian, I will attest to the simplicity of the API in just a second here because what we were able to pull off in very short time. So
Yeah. We wanted to do something to show off the bot, and we were talking about it. We have this guy here, which is a pretty basic construction. And this made a lot of sense when we're talking about Bluetooth, right? Where you have a bot and he
Yep.
might not be tethered. He's off here and you're controlling it. But then we were talking about tethered scenario where you wanted USB.
So let's go through that.
Yeah.
So this is what happens, right? So you and I talked a bit about doing Lego here
Right.
as a part of this event. And I said I need to do like USB and HID and stuff. I think I probably said I need to do USB and HID. And when I came over to your office, it was just yesterday.
Right.
I said, let's see the robot. And you're like, cool, here it is. And I was like, oh, it's Bluetooth. Crap, that's not what I wanted. I don't want Bluetooth on here. And so we're just looking at it, and I was giving you puppy dog eyes, and I was really sad and all this stuff.
I'm a sucker for that.
Puppy dog eyes on me is not very convincing, but so we got together on that, and you said, you know what? How about if I just build the robotic arm tonight?
Right.
Now, first of all, anybody who say, let me just go home and build a robotic arm tonight, that's great because not too many people are going to do that kind of hero mode stuff.
Well, the cool thing is that there's so many resources online for Lego. I mean, if you want to find anything, there's such an involved community out there. You think up something, there's some place you can start from, right? Some sort of model that you can start from, and then going from there, like with this robot, it was a matter of starting from this base unit and then saying, I want to put a phone on here and just kind of messing around until you figure it out. And I think that's a great thing about Lego. I just went out and found some instructions on a robotic arm and say, okay, well, let's figure out how we're going to use this thing. get the codes and the command strings to send to the bot, and hand them over to Pete, and he'll figure out the engineering side of it.
It's funny because I was walking around Building 9 with that robot. Nobody's looking at me funny at all.
No.
It's like, no, you just, yeah.
I've carried enough around that building that I think people are kind of desensitized.
It's like you can walk around with all sorts of crazy electronic stuff, and everybody just thinks
Clint Ruckus and his boxing robots.
Yes.
I mean,
yes. If he can drive the life-size rocket socket robots down the hallway, then I think I can get away with a little bit of Lego.
Yeah.
So you finished that last night.
Yep.
I didn't get a chance to work on the code last night. I'm in the hotel. Wi-Fi was not working for me. I paid for premium Wi-Fi, which means it works 30% of the time, not 10% of the time. So I came back today, and I said, okay, so over lunch I need to try and do something with this. And I took the sample code that was for Bluetooth and for controlling that robot, and just quite literally in a matter of well under an hour, like half an hour or so, I was able to take the command set that you sent me. It said, hey, well, to rotate it, you need to turn motor B or motor A or motor C. You
and the power settings and things like that.
And all I had to do was modify the app to be able to, one, work over USB, and two, control an arm instead of controlling the robot back and forth.
And it's really simple in the API. I mean, you're talking about switching between, whether it's a number of rotations that you have on the motor, the amount of time you want it to spin, or the degrees of rotation, the power, and the type of device that you're working with, and you send that command string, and it just does it.
So what I ended up putting together, if we can look at the PC here for a second, is, we've been talking about modern apps a fair bit, right? This is a WPF app. This is running on the desktop. Uses the same API stuff that Coding for Fun and Brian and folks have put together here. And again, looks almost identical to the code that you would call for WinRT. But in this case, I'm using, like I said, WPF to talk USB to that. And I'm able to do things like raise the arm, lower the arm. And you can tell I put this together quickly because if that is a stellar UI, I think. That's pretty amazing, don't you think? As somebody into design, did I pass or fail?
Well, I did the image on the other side of the screen there.
Yeah, so I'm not even responsible for half of the stuff.
That was whipping that together really quickly, and I said, Pete, just put some buttons on there. Let's get something on there. I was a little worried we wouldn't be able to pull it off in time.
You didn't even specify what kind of font I had to use or anything. So what I've come up here is giant font on little gray buttons. So I think that works, right?
I think design is one of those things where you really got to look at it from how are people going to use this? And that's what I find really intriguing about these kind of models, is because you have something between something physical and something digital there.
Yep.
And in this kind of audience, we're just trying to get the message across about how you can build this app. The design is all in keeping it simple and being able to manipulate the robot, and that's exactly what we did. So I think we accomplished it.
And of course, after being warned 500 times before this session not to move the robot and use the motors while somebody's talking, I'm sitting here playing with it while you're talking.
It's hard to keep your hands off of those.
So here we see it moving a bit, right? Pretty nice. It's funny because it was mispositioned earlier, and I almost sent it off the table with the first because it rotated and smacked into that display and almost went off. So there we go. Lower the arm, lower.
Yeah, and there's some things that we're not using there, and this is one of the cool things that if you're thinking about working on the platform. Now, this is a Lego education model, so it's a little more complex than some of the ones that you'd find in the retail kit.
Yeah.
But it's using, actually up here on the end, as you move the arm, this little piece here gets close to the color sensor, and it can actually sense the reflectivity.
Let me see if I can hold on. Let me
rotate it a little bit. There we go.
Oh.
Whoop.
There we go.
Yeah, and if you lower the arm a little bit, bring it down.
Here's
there
a test.
You go. See, now you see that little white piece move away, and so you can actually, with any of those sensors, you can look at the data coming through and seeing how much reflectivity is coming back from the light that's shot out of it, and how much reflects back to the little eye there. And so from that, you can judge, whether it's at the top of its movement or at the bottom.
Yep.
And so that's one of the tricks that the Lego masters use to calibrate your tool, right? So as you start up your app, you have it move up until it sees the reflectivity hits a certain point. Once it does that, you're at the top of your swing, and you can judge how much you need to rotate to go to the bottom.
That's really cool stuff there.
Yeah.
So I was going to show the code. So let's take a quick look at this, the WPF app that I have here in the IDE. So there we go. Good. All right. So this, again, WPF app. Originally, it was set to use Bluetooth communications, and there was, as part of the API that was provided here, you just set up Bluetooth communication and it's passed in the COM port. And all I had to do to make it USB, first of all, was comment that out and pass in a new USB communication object instead. It was automatically recognized. All the complexity of finding the device and knowing what to connect to was automatically handled for you behind the scenes. I kept most of the same stuff, all the other stuff the same about connecting. I kept the polarity the same, even though I probably shouldn't have because I had to reverse 2 numbers later. And then when I wanted to, say, raise the arm, really, really simple. I took the values that you gave me. You said it's motor B and it needs to be 55%, and then I just passed in a time there, which I think is like 300 milliseconds. So I picked output port.B, 55 milliseconds. 55% motor power, and then the time. And then true here, that's one thing I had to realize what to do. Because this is an ARM, if I didn't break the motors when you raised it, after I raised it, it would slowly start to sag back down again.
Right.
So I passed in true to break that.
Yeah, it's kind of like when you're moving a bot, like the other bot we have here. If you don't pass that true, it'll kind of slow to a stop.
Yes.
Which you may not want it to do if it's going to hit a wall.
Right. Yes. Yes. Having brakes when you're about to hit a wall and smash up your Lego is probably a good idea. So really, I mean, when you look at this, the code is I don't know how. So I have an EV3 at home. It's not something that I had even opened up yet. I bought it before Christmas, to play with my kids and stuff. And it's actually, I've been so busy, I just kept it under my desk. And I thought it would be really complex to get into it, programming-wise.
Yeah.
And then the fact that I was able to do this with just like a line of code and stuff was really quite good.
Well, whether you have kids or not, this is a great kind of kit to mess around with. And in terms of like this right here with the tank bot, just think of like recreating a logo type bot, right? The turtle.
Yes.
And having little control blocks that you can drag onto the interface and say, move forward 10, move forward 20, rotate, 90 degrees to the right, et cetera. And hand that off to somebody, and then they can build a little course that, you try and navigate the robot through. I mean, there's just so many things you can do with it.
So there are two sort of related things there. Like my kids, I have a Big Track at home. Do you remember Big Track? There was it's from the 70s, but they reissued them a while ago. It looks sort of like something out of Space 1999 or something. It's got six wheels total,
right, big
and you
long,
program it. You program it directly on it. You say forward 5, right 90, forward 5. So it's just like Logo.
Yep.
So you could do the same kind of thing. Do it all with like an onboard touchscreen or remotely, over Bluetooth or anything like that, and teach the same kind of stuff with kind of more creative products.
Right. Or think of if you've ever played like Robo Rally.
Yep.
Think of recreating Robo Rally with the actual robots here. I mean, there's just so many different things you can do. So I think it's a great tool to be able to utilize that and the PC. PC handling some of the rule systems and things like that you could have in a game, and then you just have the physical side as well. So.
Yeah, you create an internet-connected robot, right?
Yeah.
You could have random people on the internet controlling the robot. Do not put a camera on this robot if you're letting random people to move it around your house. But I think that would be a really cool idea. So lots of cool stuff. I have a daughter who's 5. I have a son who's almost 8. She's not quite into this stuff yet, although she does like Lego. My son it was a Lego Christmas, and I know he would be completely into this as well.
Yep.
And I've started introducing them to games that teach programming.
Yep.
Because my kids don't have a choice. They're going to end up doing this stuff in the future.
Start them off on small basic. And
it's just what happens. So, there are some board games that sort of teach programming where you have to move stuff around. And this, where you're moving something physical in the world, I think, is a really great example of something that you can really get kids into to have some fun.
Right.
And not just that. It's also fun for adults as well.
Well, think of the Internet of Things, right?
Yes.
I have a lot of home automation things that I have set up at home. Sometimes you have something that's a physical switch that you need to automate, like your coffee maker, and you want it to start in the morning.
Yep.
You can set up a nice little switch, have the motor move, and hit the switch to turn on your coffee when you wake up. I mean, all those kind of things can be all controlled through Z-Wave, connected through to Lego, and I mean, it's just amazing what you could.
And I saw somebody create a Lego 3D printer. Right, which I thought was interesting. I forget what it used for material. It wasn't hot. You're not going to melt ABS on something made of ABS.
Right.
But it was really interesting how
I've seen a router too, where they had a drill that drilled out of foam. Yeah.
So some really cool things that you can do with this. And really, I think that kind of wraps up our time here.
Yeah, we could spend all afternoon coming
we're
up with
just gonna-
things we would do as a project, but we want to see it from you guys. So,
Yeah.
you know, if you do something, definitely tell us about it.
Yeah, we'd be interested in talking about it, showcasing it, making some noise, show us some cool stuff.
Yeah, get out on Codeplex.
Cool. All right.
Great.
Well, I really want to
thanks,
thank
Pete.
you for joining,
Sure.
and thank you for building this robotic arm last night, and
That
for
was
getting
fun.
the API over and stuff, because that was a huge lifesaver. And this talk would have been really boring if we didn't actually have any models that worked. So again,
We
thank
could
you
have
very
just played Dan Fernandez's video, but you
much.
know.
Or I could just have been like, see how it moves, and hope nobody saw my hand, right? So cool.
Great.
Thank you very much.
Thanks, Pete.
Thanks.
Thanks.